Hello students. As you know, number system is a very important topic in many competitive exams like CAT, XAT, NMAT, MAT, etc. So today we are going to cover a part of number system, that is factorial. Before starting this session, let's have overview. First of all, we will learn how to find power of a prime in factorial. Then we will learn how to find power of a composite number in factorial. Then we will practice some example based on factorial and base system, that is a combination of two topics. Then we will practice some example based on factorial and factors, again a combination of two topics. Then you will have some practice questions based on factorials. So let us start this session. Let us take a smaller example to understand this concept. So my question is, find the highest power of 2 in 100 factorial. What is the method to do this? We'll successively divide 100 by 2. First of all, we will take 100 by 2, which is 50. We'll consider only quotient. Then we will take this 50. Then we will take 50 by 2, which is 25. Then we will take this 25. Again, we'll divide it by 2. It comes out to be 12.5. But we will consider only the integral part. That is 12. Then again we'll take 12 by 2, which is 6. Then we will take this 6 and we will divide it by 2, which is 3. Then we will take 3 by 2, which is 1. Further we cannot move. Why? Because if we take 1 by 2, its gent will be 0. So what is the answer in this case? We'll add up all the numbers we got as quotient, which comes out to be 97. That's why this is the answer. So what is the highest power of 2 in 100 factorial? That is 97. Let us take one more example. So my question is, find the highest power of 4 in 100 factorial. Since 4 is a composite number, we cannot follow the same process. So what is the criteria to do this? Since 4 can be written as 2 square, I'll write the prime factorization of 4. So we will find the power of 2 in 100 factorial that we have calculated. As we know, 100 factorial, 2 comes 97 times. If 2 comes 97 times, 2 into 2, that is 2 square. That will come how many times? It will come 97 by 2 times, which comes out to be 48 times exactly. So that is the answer in this case. So that was the method to solve factorial questions. Let us start with more examples. Question number 1, that is a simple question based on definition of factorial only. It says, let x a factorial is x into x minus a into x minus 2a so on up to x minus ka, where k is the greatest integer for which x is more than ka. Find 72 8 factorial and 18 2 factorial. So let us take 72 factorial divided by 18 factorial. So if we go by definition only, we'll get 72. Then we will get 72 minus 8, which comes out to be 64. If we go in same manner, we'll get 56 into 48 into so on up to 8. Division by, again we'll follow the same definition. It will be 18. 18 minus 2, 16. 16 minus 2, 14. So on up to 2. So as you can see in numerator, we have all the multiples of 8. First 9 multiples of 8. So if we take 8 out of every multiple, 8 will come 9 times and we are left with 9 into 8 into 7 so on up to 1, which is nothing but 9 factorial. In the denominator, we'll follow the same process. As you can see, in denominator we have first 9 multiples of 2. So from every multiple we have taken 2 out. So we are left with 2 raised to power 9. into 9 into 8 into 7, so on up to 1. This is 9 factorial and this is also 9 factorial. It got cancelled. That's why we are left with 8 raised to power 9 divided by 2 raised to power 9, which we can write 4 raised to power 9, and this is the answer in this question. That was a very, very basic medium level question. So let us move further. Question number 2. Good one, a difficult one. It says if 120 factorial given in decimal system, given in base 10, when converted in base 18, let the number becomes n, with how many zeros n will end? First of all, to understand this question, let us take a smaller example. Let us take 18. 18 is given in base 10 and we want to convert this number in base 3. Let this number be m. So my question becomes, with how many zeros m will end? First of all, how will you convert any number from decimal to another base? We'll do it by successive division. So what is the criteria? First of all, we will take 18, then we'll successively divide 18 by 3. We'll write the quotient here and the remainder here. So 18 when divided by 3, what is the quotient? 6, and the remainder is 0. Then we'll divide it again by 3. The quotient will be 2 and the remainder will be 0 once again. Then again we will divide. We'll get quotient as 0 and remainder as 2. So what is my number? It will be written in the reverse order, which is 200 in base 3. So simply we can say when 18 given in decimal system, when this number is converted in base 3, it will end in 2 zeros. Do we have any shorter method to do this without using successive division? Yes, we do have. How can we do this? As you can see, if we are getting a remainder of 0 2 times, it means 18 is divisible by 3 twice. As you can see, 18 can be written as 2 into 3 square. It means there are 2 3's present in 18. That's why this is divisible by 3 twice. So simply we can judge that what is the highest power of 3 in 18? That is 2. That's why it will be divisible by 3 twice. So simply we can say answer will be 2 in this case. So let us move to our original question. Now it was 120 factorial given in base 10 when converted in base 18, with how many zeros it will end. So my question will become, with the similar logic we can say that we will find highest power of 18 in 120 factorial. Now since 18 can be written as 2 into 3 square and 3 is the bigger prime, that's why we will check the power of 3 only in 120 factorial. Now power of 3 will be, first of all we will take 120 by 3, that is 40, then 40 by 3, that is 13, then 13 by 3, 4, 4 by 3, 1, which comes out to be 58. So power of 3 in 120 factorial is 58, but we need power of 3 square. It will be half of 58, which is 58 by 2, that is 29. So what is the highest power of 18 in 120 factorial? It will be 29 only. Now the next question. It says find the smallest positive integer n such that n factorial is a multiple of 2 raised to power 100 into 5 raised to power 100. Now what is 2 raised to power 100 into 5 raised to power 100? That is nothing but 10 raised to power 100. It means my question becomes, for what smallest value of n factorial will end in 100 zeros? Because every 10 is corresponding to 1 0 at the end. To calculate number of tens, as we know 10 is 5 into 2 and 5 is the bigger prime. That's why we will calculate the number of 5s in n factorial and it should come 100 times. So how we calculate number of 5s in n factorial? First of all we take n by 5, its gent, Then we will take n by 5 square, the integral portion. Then we will take n by 5 cube, its integral portion, and so on up to. We are going by approximation actually. Can you say this is a GP with infinitely many terms? We have a formula for that to find the sum of infinitely many terms GP. That is A upon 1 minus R. That is first term upon 1 minus the common ratio, which comes out to be n by 4. And that is approximately equal to 100, since we need 100 zeros at the end. So we can say that n is close to 400. I'm not saying that n's exact value is 400, but n will be near to 400. It will give you a range. So if we calculate number of zeros or number of 5s in 400 factorial, that is, we will divide 400 by 5, which comes out to be 80. Then we'll go by successive division. 80 by 5 is 16. Then 16 by 5 is 3, which comes out to be 99. It means in 400 factorial, there will be 99 zeros at the end. But we need 100 zeros. It means we need one more multiple of 5. So, taking one more multiple of 5 to 400 factorial, we'll get 405 factorial. As 405 is a multiple of 5 but not a multiple of 25. That's why we can say that 405 factorial will end in 100 zeros, and this is the answer in this case. That is the smallest value of n we can take. So n will be 405. Suppose my question is, for how many values of n factorial will end in 100 zeros? Then the answer will be, we can consider 405 as n, 406, 407, 408, 409. But if we take 410, it will give you one more zero. That's why there are 5 values of n are possible, for which n factorial is a multiple of 2 raised to power 100 into 5 raised to power 100. And smallest of them is 405, and that is the answer to the original question. Now the next question, question number 4. N factorial when converted is in base 21, that is n factorial, that is given in base 10. When this is converted in base 21, it is ending in zeros, and the number of zeros are 21. Find the least possible value of n. This is my question. So, what is the meaning of this question first of all? If n factorial when converted in base 21 is ending in 21 zeros, it means the highest power of 21 in n factorial is 21 only. So my question becomes, for which smallest value of n factorial, the highest power of 21 in n factorial is 21. Since 21 can be written as 7 into 3 and 7 is the bigger prime, that's why we will calculate for what smallest value of n factorial contains highest power of 7 as 21. So we will apply the same logic, successive division. How can we calculate highest power of 7 in n factorial? First of all, we will take n by 7, its integral portion. Then we will take n by 7 square. Then we will take n by 7 cube. Every time we are considering gent only. So on up to. So again, this is a GP. So simply we can say this is n by 7 upon 1 minus 1 by 7, which is 21. So n by 6 is equal to 21. N will be 126. So we have got an idea of n's value, and it is 126. If we calculate number of 7s in 126 factorial, we'll get again successive division. We'll take 126 by 7, which comes out to be 18. Then we will take 18 by 7, which comes out to be 2. So in total, what is the highest power of 7 in 126 factorial? That is 20. But we need 21 times 7. That's why we need one more multiple of 7 here. Since 126 itself is a multiple of 7, we will add 7 to this, which comes out to be 133. So 133 factorial will end in 21 zeros when converted in base 21. That is the answer for this question. Now question number 5. Let m be the largest positive number containing exactly 3 factors that divides 25 factorial. Find the sum of digit of m. Now this was an important line, that the positive number containing exactly 3 factors. So if we take any prime raised to power 2, the number of factors of this number is 3. So as we know that 25 factorial primes appear in this number are 2, 3, 5, 7, 11, 13, 17, 19 and 23. Now we need the largest positive number. That's why we'll start with the biggest prime, that is 23. But highest power of 23 in 25 factorial is 1 only, because 23 appears in 23 only. Similarly, we cannot take 19 because 19's highest power in 25 factorial is 1 only. Similarly, we cannot take 17 because highest power of 17 in 25 factorial is 1 only. Similarly, we can reject 13, but if we take 11, 11 comes twice in 25 factorial, once in 11, once in 22. That's why 11 square will appear in 25 factorial, and that is the largest number which is satisfying this condition that it contains exactly 3 factors. Now what was the question? Answer is not 11 square in this case, because the question was find the sum of digits of m. What is m here? 11 square, that is 121. So what is the sum of digit? That will be 1 plus 2 plus 1, which comes out to be 4. That's why 4 is the answer in this case. Now question number 6, important question and the difficult too. N factorial is ending with m zeros. N plus 2 factorial is ending with m plus 2 zeros. Also 90 is less than equal to n less than equal to 190. Find number of possible n's. So let us start. See, it says n plus 2 factorial. Since n plus 2 factorial can be written as n plus 2 into n plus 1 into n factorial. Since n factorial already contains m zeros and in total we need m plus 2 zeros. It means we need 2 zeros extra. These 2 zeros can come from n plus 2 into n plus 1. There can be 3 possible cases. Either n plus 2, that can be a multiple of 25, because in that case we'll get 2 zeros extra. Or it can be a multiple of 25, I mean n plus 1. Or there can be one more case where n plus 2 is a multiple of 5 and n plus 1 is a multiple of 5. Of course, third one is not a possible case, because n plus 2 and n plus 1, they both are consecutive numbers, because there is a difference of 1. Since they both are consecutive numbers, they both cannot simultaneously be multiples of 5. So this case is rejected. These are the only 2 possibilities. It means in this range 90 to 190 will consider all the multiples of 25. So let us see. So if we take n plus 2 as 100, n will be 98. So whatever be the number of zeros in 98 factorial, n plus 2 will be 100 factorial, and 100 factorial is 98 factorial into 99 into 100. Since we are assigning 100 to 98 factorial, that's why there will be 2 zeros extra in 100 factorial. That's why this is a possible case. If we take 99 as n plus 2 will be 101. That is again a permissible case. But if we take n as 100, n plus 2 will be 103 factorial. This is not a possible case, because 103 factorial and 100 factorial, the number of zeros are same in this case. That's why this case is rejected. So corresponding to every multiple of 25, there will be 2 cases. Let us write all the possible cases. So they are 100, correspondingly n's value is 98, 101, 99, The second multiple in this range of 25 is 125. So if we take 125, it will be 123. If we take 126, it will be 124. But we cannot consider this case. Why so? Because if we take 123 factorial and we multiply this by 124 and 125, since 125 is 5 cube, so there will be 3 zeros extra. That's why we have to reject these cases. So we'll move to the next multiple of 25, that is 150. Correspondingly, you will write the values of n. Now you got the idea, so no need of writing n value. Then what is the next multiple of 25 in this range? That is 175. So we can write 175 and 176. So these many cases are possible in this range 90 to 190. So what is the answer in this case? 6, not 8. So 6 will be the final answer in this case. Now these are some practice questions. And these are the answers. To learn more concepts and shortcuts, log on to hitbullseye.com. Happy learning. Thank you so much.